Hello, and welcome to your factoring review. Factoring is a concept that you first learn in Algebra 1, so that's either 8th or ninth grade for most of you. And it's a concept that you really need to remember all the way through the rest of your math classes. It's super important to be able to solve these quadratic equations, and so this video is just going to take you through a brief review of the different types of quadratics you might have to factor. There is more information about this, and you can totally find it anywhere on the internet. However, this is just a real brief run through. So let's get started. Our goal is to go through and be able to factor any sort of equation that's in the form of ax squared plus bx plus c. So we're going to start with probably the most important thing that you'll need to remember, and that is whenever you're trying to factor any equation, you should really always begin with a GCF, where your GCF is your greatest common factor. Now, the common part is super important because this factor, or this value, this number that goes into all the other numbers, has to be common to every single term. So most of the equations or expressions that we look at are going to have three terms, and if we're looking for a common factor, we need to find a value that goes into all three of these terms. In this case, I think 3x squared, 6x, and 9, it looks to me like all three of those have the value 3 in common, so I'm going to factor or divide out the number 3. And when I do that, we know that there were three terms inside, so there need to stay three terms inside. When I take the 3 out of all of them, we're going to be left with 1x squared, 2x, and 3. And it's really easy to check this by just taking your 3 and distributing it back inside. Is 3 times 1 equal to 3? Yes, it is. Awesome. And so on and so forth. As a reminder too, since we'll see this fairly often, you do not need to write the 1 in front of x squared. You can just write x squared plus 2x plus 3. So there's a quick review of your greatest common factor. We're going to try one more of those just to make sure you're confident, and then we'll actually get into factoring. This greatest common factor we're doing right now is a piece of factoring, and it's something you always need to look for when you start. It's your first step. You're looking at it going, okay, is there a greatest common factor? Well, if we look at this next one, we again have three terms here. Okay, and what do they have in common? Well, at first glance, it kind of looks like they have a 2 in common, but this x cubed has a 1 in front, and we can't divide a 2 out of there, so the 2 isn't it. But what else do they have in common? Well, hopefully you're shouting, oh, they have an x in common, because they do. So we're going to go ahead and take an x out of each of these. So I'm going to divide the x out front, and let's see what that leaves inside for the rest of these. Well, x cubed is really x times x times x. We took one of those x's out, so instead of x cubed, we're down to x squared. There's still going to be a 2 here and still a 4 over here. X squared is x times x. We took one of the x's out, so there's still an x left. 4x just had one of the x's, but in this x we stole out front as well, so I think there's just a 4 left, and at this point we're done. Right? So greatest common factor first. And the reason we want to take a greatest common factor out is it's going to make the values or the numbers inside smaller, and smaller numbers are going to be easier for you to work with. You don't have to take out a greatest common factor, but it will make your life easier. So let's go through. The first factoring method that we're going to review is the box method, and sometimes your teachers will call it the Xbox method, and I'll try to show you a couple different ways this might have been presented to you. The reason I like the box method is because it works every single time. On every equation that we look through, and we're going to look at about 8 total equations today, you can use the box method. That's what we start teaching you, and then we learn other ways to factor after that. You can always use the box method. So let's get to it. First thing, big first step, greatest common factor. So looking at all three of these terms, and I'm going to put the 1 in front, is there something in common? Well, 2 doesn't go into every number, every term doesn't have an x. I think there's nothing in common besides a 1. You can always divide out a 1, but that's not going to make the numbers inside smaller, so no greatest common factor. We're just getting right to the box method. Okay, so what do we need to do for the box method? Well, since it's in there, it's a box, we should probably draw the box that we're going to try and do. So eventually, I'm going to go ahead and fill in this box. And you've probably used these for multiplication before and hopefully for factoring before as well, so you probably know where everything goes. But just a brief review. We need to fit this equation into the box over here. Okay, the x squared always goes on the upper left, the one without the x always goes on the lower right. The last two boxes are reserved for x's, but the problem is we've used this 2x squared, we've used this minus 15, there's only a 1x left and there's two boxes, so how do we split the 1x? Now, the really on top of it ones of you might say, well, we could split it into 0.5x and 0.5x, and you're right, but we could also split it into 2x and negative 1x. And what we need to realize though is however we split this, these two terms need to combine or add like terms together to make this 1x back. So actually I'm going to sort that over on the side. I guess I can just erase here quickly. So we know that these two blanks right here, and I'll use a different color for them, these two blanks have to add up to equal the 1x that we started with, whatever they are. But the problem is we just saw is there's an infinite number of ways to do that. 2 minus 1, 3 minus 2, 4 minus 3. So we need to narrow it down because only one combination is going to actually work or help us factor this expression. So the other thing we need to do is we're going to take those same two numbers, but instead of adding, they're going to have to multiply to equal something. And this is the step that everyone forgets, so it's probably worth remembering. These two are going to have to multiply times multiply to equal the first times the last. So I always up here just want to do a quick 2x squared times negative 15, and that's going to give me negative 30x squared. So these two values also have to multiply to equal negative 30x squared. Alright, now we can go through and start filling this in. The same two numbers have to fit in the blanks here and here. The easiest way to do that is to list factors of 30. We gave our students a factor sheet that was really nice that goes through and tells you all the factors of 30 super quickly, but if you don't have those factors, I can quickly list them down below. We have 1 times 30, right? Sometimes you'll see it's like a rainbow method, and then I just go up by 1, so then we have 2 times 15, that makes 30. 3 times 10, that makes 30. 4 doesn't go into 30, but 5 does. 5 times 6, and now our numbers are right next to each other, so I think we're done. So out of all of these, they multiply to equal, I just did positive 30, but they're also going to have to add up to equal 1. So maybe another way to think about this is which of these factor sets are 1 apart? Well, 1 and 30 are 29 numbers apart. 2 and 15 are 13 numbers apart. I think hopefully you can see that 5 and 6 are 1 apart. So that's probably a good place to start. Let's see what happens if we use 5x times 6x. And I put the x's in there because x times x is going to get you x squared. And then 5x plus 6x, that would give you 11x. So I think we're going to probably have to make one of these negative to get to 1x, and that would make sense because a negative times a positive is a negative. The question is which one, and it is important. Well, if I made this a negative 6, 5 minus 6 would be negative 1, and that's not what we want. Instead, I think we'll want this to be negative 5. Negative 5 plus 6 is positive 1. Negative 5 times 6 is negative 30. Awesome. We've gone through and we've filled in this box, and I'm going to rewrite this to give myself a little more space. Okay, so we found that the inside is going to be negative 5x and 6x. And again, the order doesn't matter here. We could have put a 6x down here and a negative 5x up here. That's totally okay, right? Nothing too bad. However, we're not done. All we did is we have these four terms, which is really the exact same thing as what we started with, right? If you were to take these four terms in here, combine like terms, it's exactly what we got over here, and that's the point. We just wanted to rewrite what we started with as something a little bit more expanded that will fit in the box. Now, last part is we need to figure out the outsides of the box. These are the actual factors. And the way we do it is we find what they have in common. So for example, I'm going to look at this 2x squared and 6x and think, what do those two have in common? This is that greatest common factor that we did up above. What's the greatest common factor? Well, we should notice that we can divide them both by 2. 2 goes into 2 nicely, 2 goes into 6, and we can divide them both by x. X goes into x squared, x goes into x, and that's it. From here, we have to do another one. So we look up here and we say, okay, what can we divide these by? Well, they both clearly have an x. However, no nice number goes into 2 and -5 besides 1. 1's the smallest we can go, so I think 1x is that. At this point, we can check to see if we're doing everything right. Because we know to use a box, these two outsides have to multiply together to equal the inside. 2 times 1 is 2, x times x is x squared. That's looking pretty darn good. In fact, we didn't even need to do this last piece right here, because we could have just reverse engineered and said, oh, 2 times what gets us 2? Well, 2 times 1. X times what gets us x squared? X times x gets us x squared. So that's just another way to fill out the outside of the box. Right? So 2x and 1x. And notice we don't even need the 1 here. 2x times x is 2x squared. Okay? So let's just do that reverse engineering. 2x times what gets us 6x? Well, 2x times 3 gets us 6x. Another way you could have found the 3 is said, what do these two terms have in common? Well, we could divide 6 by 3 and 15 by 3. 3 is the greatest common factor to both of those. So just another way to go about it. And then x times what is -5x? That's got to be -5. And then I tell my students, look for the bonus box. So what's -5 times 3? Well, -5 times 3 is -15. If those match up, you know you did it right. And we could go ahead and find our final factors. Our factored form for this are just going to be these two sides. It's going to be x with a +3 and 2x with a -5. And we're done. There's our factored form. Now, I mentioned at the beginning of this problem that you could have called this the Xbox method because some teachers will organize their work differently. So what they'll do, instead of writing them out like this, they'll draw a nice fancy X over here, and that's fine. Right? It's the same thing. And for this fancy x, on the top, they'll go ahead and put what the two numbers have to multiply to equal. And on the bottom, they'll put what the two numbers have to add to equal. Right? That's exactly what I did here. It's just written out over here. And then on the sides, they'll figure out, oh, what are those two numbers? Those two numbers were -5x and 6x. You can multiply to make the top and add to make the bottom. I don't do the x because I don't know why you organize it with an x, but it's perfect. There's nothing wrong with it. I like writing it out with the actual symbols. What multiplies, what adds. So there is our factoring using the box method that works every single time. Let's try another one, but go faster this time. So second example, 6x squared minus 16x minus 32, and we need to remember what's the first thing we always look for? Greatest common factor. That's the one. So we're going to go through and see what do each of these have in common. What goes into 6? 1 goes into 6, but that's not useful. 2 goes into all of those, I think. 3 doesn't go into 16. 4 doesn't go into 6. 5, 6 doesn't go into 6. I think 2 is probably our greatest common factor here. So the first thing I'm going to do is divide out a 2 from all of these. And that's going to give me, let's see, just putting in these blanks here. 6 divided by 2 is 3. 16 divided by 2 is 8. And 32 divided by 2 is 16. Okay. So what that tells me then is my final answer that's going to pop up over here is going to have that same 2 on the outside, and then we're going to factor just the part that I wrote in black on the inside. Okay, so the 2 is not going to do anything else. We're really just going to focus on this part right here. So let's get everything set up. We know that we're going to have our box. The box is going to contain the inside. It's going to have 3x squared, -16. There's 2 spaces left, but only a -8x left, so we have to split that -8x up. Alright, how do we split it up? Well, we need 2 numbers that add to equal -8x, and we need those same 2 numbers to multiply to equal, and this is always the tricky part, the first times the last. 3 times -16 is -48x squared. Alright, so what are those going to be? Well, we need factors of 48. There are a lot of factors of 48, but I'm feeling 12 and 4 here. You know, 12 times 4 is 48, and 12 and 4 are 8 apart. I bet this is going to work. Let's see, 12x and 4x, 12x and 4x. That multiplies. To get -8, I think this needs to be a -12, and we're in business. -12x and +4x. Let's figure out the outsides. 3x squared and 4x, I think they just have an x in common. So that means that x, let's see, x times what gets us 3x squared? Well, we need a 3 and another x. And let's just double check. Do 3x squared and negative 12x have a 3 in common? They do, and an x. Yes, I think we did that just fine. So this is looking good. We're just going to reverse engineer the rest. X times 4 is 4x. 3x times negative 4 is negative 12x. Bonus box, negative 4 times 4 is negative 16. It looks like we've done everything right. So final answer, I'm just going to write everything up here. 2 times 3x with a positive 4 and an x with a negative 4, right? We just took these two, put it up there, and we are set. Now, what if you didn't notice there was a greatest common factor? 6x squared minus 16x minus 32. Could we still do the box method? Sure. The problem with the box method is you'll need two numbers that add to make negative 16x, that's fine, but then they have to multiply to equal the first times the last. And let's see, 6 times 2 is 12, 18, 19. I don't know all the factors of negative 192, right? 48 I could look at, I knew most of those factors. This one's much harder. So by taking out a greatest common factor, you just make your factoring life easier. Okay, so at this point, if you're comfortable doing the box method, you're going to be really successful. However, I wanted to take some time and show you a couple shortcuts just to make your life easier, because I certainly don't use the box method every time. In fact, there are a bunch of, in fact, probably the majority of problems you won't have to use the box method. Can you? Sure. But should you? Probably not, because we can do it faster. So the first shortcut is factoring if a equals 1. And we are not going to use the box here. What we're going to do instead is, well, I guess we should talk about what it means for a to equal 1. Remember we said at the very beginning we're trying to factor these ax squared plus bx plus c quadratics. When a is 1, that means the number in front of x squared is 1. And you'll notice in this equation over here, x squared plus 6x plus 8, the number in front of x is an invisible 1, which means we can use this nice little shortcut. Our shortcut is we're going to skip right to our answer without having to use the box. However, we still need to do two things. We still need to find the two numbers that add to break up the 6, and I'll put the x here for now, and multiply to equal the first times the last, which is going to be 8x squared. Okay. Well, what multiplies to make 8? 1 times 8, that doesn't add to make 6. 2 times 4, oh, that does. 2x and 4x, 2x and 4x. So this is just like how you start the box method problem, but we get to skip the box part, because if a is 1, all we really care about are these two values right here, not even the x's with it, right? I'm going to end in a positive 2 and a positive 4 right here. What goes in front has to do with how you'd multiply all this back out. We know that this term times this term when you distribute has to equal the first term. What times what equals x squared? Well, the only nice integer ones are x times x. And so we're done. So whenever a is 1, these these variables in front are going to be x, and the 2 at the end are the numbers that add and multiply, and then that's it. It's always going to be x plus something times x plus something, or maybe a minus. Okay. Example 2 is in the same category, so we should expect to be able to use the same shortcut, but there's a little issue. The number in front of x, our coefficient, is 2. And so we can't use the shortcut. But wait, I think we forgot our big first step, which is always look for a greatest common factor. So what is common to all three of these? Well, 2 is the smallest number, and there's only two things that go into 2, 1 and 2. So I think we can go through and divide everything by 2 here. Let's see if that works. So I'm going to do 2, big set of parentheses. That's going to give us 1 when we divide it out, minus 6x plus 8. Okay. And then I think we're probably back in business here. This is looking pretty good. We know that our final answer then is going to have a 2 out front and then 2 sets of parentheses. And notice here a is 1, so let's use our shortcut. We need two numbers that add up to equal negative 6x and multiply to equal first times last 8x squared. Super similar to the one we just did, except this one I think is going to have some negatives in there. It's probably going to be a 2x and 4x again. But 2 plus 4 gets us positive 6. If we just made one of them negative, then this would become negative. A negative times a positive is a negative, so I think they both need to be negative. These ones both need to be negative. So at this point, I think we've got our answer. It starts with x's. We just use the two values that are here, so -2 and -4, and we're done. Easy peasy. All right, last set. This is factoring using two terms. Now, two terms is kind of weird because, again, we've spent time talking about ax squared plus bx plus c. And I also mentioned that the box method will work for all of these problems, but the box method needs three terms. So realize that for each of these, you could give them three terms, and you could use the box method. If you're like, I just want to learn the box method, I just want one way to do it, then it works for these as well. And I'm going to show you how to set those up first, and then I'm going to show you the shortcut. So, box method wise, if we wanted to go through and tackle x squared minus 3x, you'll notice that it has the x squared part, it has the bx part, it's just missing the c at the end. Well, if there's no number written and that's adding, then we could manipulate this equation and say, oh, this is the same thing as x squared minus 3x plus 0. And then you can use the box method. Two numbers that add, two numbers that multiply, and go from there, right? In fact, this one has an a of 1, so you could even use the method right up above. But we're not even going to do that, right? That's how you could set it up, but this is just another shortcut. If there's two terms here, the first thing, big first step, is what do they have in common? Well, looking at these two, hopefully you can recognize that they each have an x in common. So all I'm going to do is divide out the x from both of these. X squared, if you take out one of the x's, just leaves you with x. X times x is x squared, right? And negative 3 times x just has the one x there, and if we steal it out to the front, there's just a 3 left. Now, notice what makes something into factored form. Factored form means you have two or sometimes more factors, but each of these factors have to contain an x, right? Those each contain an x. If we jump up here, these each contain an x. There is this bonus 2 out here that's a factor. We don't really care about that, though. We need at least two factors that where each one has an x, though. And if you look down here, we actually have two factors. X is multiplying times the other one, and they each contain x. So we're actually done here. This is really the common way to write this factored form. Now, some of you, it might make you more comfortable to see the two factors the same way we've written them in the past, where here's your x minus 3 and here's your x. But again, as we talked about for this problem, if there's nothing adding to the x, we can always put a plus 0, and this is the same factored form. So when you only have two terms, factoring is really, really fast. You just identify the greatest common factor and you're pretty much done. Okay, let's take a look at these next two. I have the ax squared, I have the bx, but there's no c. So again, if you wanted the box method, just put a nice little plus 0 and do your box method. However, we're trying to go faster. So, greatest common factor. Let's look at these two, and you might say, ooh, aha, they both have an x in common again, just like the one we just did. Well, you're totally right. So they do have an x in common. And that's going to leave me, instead of 6x squared, it's just 6x, and instead of 9x, that's just 9. But the problem here is that although you have put this into factored form, this is right, you wouldn't see this as an answer on a multiple choice test, because in this bigger factor, there's still another factor that we missed from the beginning. There's still something that each of these have in common. What can you divide into both 6x and 9? Well, you can divide a 3 into both of those. So I'm going to go ahead and divide the 3 out. It's going to multiply with the x out front. And let's see what that changes to the two terms inside. 6x divided by 3 is 2x, 9 divided by 3 is 3, and this is probably a more accepted factored form, right? Again, if you wanted to write it as two sets of parentheses, you could say 3x plus 0 times 2x plus 3. This would be a much more, this would probably be the answer you'd see on multiple choice, but a much more common answer. Traditionally, if there's anything common in a factor, you're expected to divide that out to the front. Okay. Last two. Okay. This one, we have an x squared, that's like our ax squared, and a minus 16, which doesn't have an x, so that's got to be the c. So we have the first one and the last one, but not the middle one. Could you still use the box method? Absolutely. We would just rewrite this. We'd say there's an x squared, let's leave a gap, minus 16. How many x's are here? Well, there are 0 x's. and now you have 3 terms and you can go use the box method. However, there is a shortcut for 2 terms. We'd probably want to look at that big first step and we'd say, do x squared and minus 16 have anything in common? And I don't think they do, actually. But this pattern is known as a difference of squares. Why is it known as a difference of squares? Well, you'll notice that we can actually take each of these and rewrite them as something squared. X squared, well, x times itself is clearly x squared. However, we can rewrite 16 as one number squared. What number times itself gives you 16? Oh, that's got to be 4. 4 times itself is 16. So, why is this known as a difference of squares? Well, it's known as a difference because whenever you subtract two things, terms, values, that's always a difference. And then why is it known as a difference of squares? Because you can rewrite each term as something squared. Right? It's a difference of squares. Of course, we're not done. That's not the factored form, but the factored form is very easy. When you want to factor something that's a difference of squares, you just write your 2 sets of parentheses. Right? We have our x and our 4, right? Those are the squared things. I'm going to write it a second time. Now, if you multiply this out, let's see if it matches what we started with. X times x, that's definitely x squared. Is 4 times 4 equal to negative 16? I think hopefully you've realized that one of these will have to be positive and one negative, and then you're done. That is your difference of squares. You could try multiplying all this out, get all 4 terms, and prove to yourself it matches this. It does, and it's kind of cool, but that's how easy a difference of squares is. You figure out what 2 things are being squared, and then you rewrite it. Okay, last one. 18x squared minus 50. Same thing as before, you could treat this as 18x squared plus 0x minus 50 and use the box method, but this is probably going to end up being a difference of squares. Let's take a look. I think we're going to run into a slight issue though, because 18, I don't know what times itself equals 18. Right? 9 times 9 is 81, not 18. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. It skips over. Oh, but I forgot the big first step. We need to look at these two and think, what do they have in common? And I think they each have a 2 in common. So let's factor out greatest common factor of 2 from each of these and see what that leaves. 9x squared minus 25. All right, well, leaving some space, I know then that my final answer is going to have a 2 and then 2 sets of parentheses, right? The 2 is staying, so we're just going to work with the inside. So I'll rewrite the 2 just so we can see what I'm doing here. 9x squared, could we rewrite that the same way we did over here? What times itself gets you a 9 and an x squared? I think that would probably be 3x. 3x times 3x is 9x squared. And what times itself gets you 25? Well, it's got to be 5. 5 times itself is 25. Once we've rewritten this as a difference of squares, factoring is easy. 3x minus 5, 3x plus 5, and done. So at this point we have a couple things to think about. To factor, you can always use the box method. You don't even need the greatest common factor that we talked about. Really, as long as you can get through the box method, you'll be fine. However, to be a really efficient factorer, you need to recognize or look for a greatest common factor every time. If a ends up being 1, use the shortcut, skip the box. And if there's only 2 terms, you never need the box. You can either just divide out a greatest common factor, and as long as x is in both factors, you're done. Or if it's a difference of squares, rewrite it as a difference of squares and quickly factor. I've skipped over a lot on this video, like how to factor by guessing and checking, any number of ways, how to check to see if your factors are right, but that's because this is meant to be a review. You're supposed to know how to do this and you may have forgotten, so that's the point of this video. Hopefully that was helpful, and please let us know if you need any